Ciao friends! In this video we're going to see how to debug DAX measures. We will see 4 different techniques to inspect the evaluation of an intermediate step of the calculation of a measure, to locate a problem in the calculation and fix it. We will see how to use variables in your measure to just use the Power BI desktop as a way to investigate in the intermediate result of a measure by just using the same report you had at the beginning. But then we will use 3 other techniques that use different external tools to help us doing the job. We'll see how to use DAX Studio, executing queries and manipulating the code in the DAX Studio editor window. We will see how to use DAX debug output, which shows the output of the evaluate and log function we can use to change the code of the measure to inspect the intermediate step of a calculation. And finally, we will see the DAX debugger feature in Tabular Editor 3, which is actually the only tool available that performs a real debugging session, executing the code step by step without requiring to touch the code of your report. So let's start with the demo. So let's start looking at the report I prepared to test how to debug DAX measures. In this report, we have a simple measure, average transaction, which computes the average amount of the transaction for the selected transaction in the sales table. We used to group the data by brand and year. So if we take a look at the content of the report, we see that we have the brand selection for each row, a different brand. And we have 2 years, 2018 and 2019. It's good to know that we have actually 2 years selected in the filter pane, so we don't have all the years that we have in the model. And the total column has the amount for the 2 years together. Now, this measure works. The measure that we want to analyze that has something that doesn't work correctly is the delta average. The idea is that this measure should show the difference as a percentage between this number, the average transaction for the selected year, and the average transaction for all the years selected. So the expectation is that the delta average in the total should be always 0, because we compare the number with the same number. So the difference should be 0. And the difference should be a different number, of course, for every year. Every brand should be different. Of course, we see now that there is something strange here. Actually, the number is 0 just for the grand total. So there is a number that is correct, but the number by brand is not correct. So we have to investigate on the reason why this is not working as expected. So we take a look at the measure. The measure is defined as a division between the average transaction, which is the measure we have seen before, and the same measure computed using all selected. And of course, we subtract 1 to get the number as a percentage. Now, there is something wrong, so the goal now is to investigate how to fix the calculation. We can see that the right number is something that we already prepared in another measure. So if we take a look at this measure, the delta average correct, you see that the number we expect to get as a result is this, 0 for the grand total. And as you see, year by year, the number should be different because actually we are comparing the number of the measure average transaction. So the number we see, let's see if I can highlight, the number we see here is probably compared with a different number other than this average transaction. So the goal of the next part is to see with different techniques how we can investigate into the problem, how to execute the calculation step by step to figure out where the calculation is failing, and of course, how to fix the code. The first technique we use is just using Power BI Desktop, the regular editor, and we manipulate the measure, introducing variables and looking at a particular technique of writing DAX code that makes it easier to investigate in where a calculation problem could be. So let's go to our measure. So let's restore the report that has only average transaction and the delta average. Our measure, delta average, is written this way at this point. And what we want to do, we want to split the calculation in several steps so that it is easier to isolate the result of each step in the calculation. How do we do this? Well, first of all, we create a variable, which is the current value that we use in the numerator of the divide function. So we move this average transaction into the variable current value. And of course, at the end, we want to return this value. So this is one technique. I could change the code step by step, always keeping a version of the measure that continue to work. So if now I click enter, this should continue to work, continue to return the same number. The reason why I'm doing this split in different variables is because I want to obtain a structure that makes it easier to extract the value at a particular point in the calculation. So let's continue doing this work. So I can isolate this other calculation, the denominator of the division, and I store this into another variable. For example, reference value is equal to this calculate. At this point, I replace this calculation with reference value. But I don't stop here. So you see that the technique I used in the divide was to use divide minus 1. But actually, one thing I could do, I could compute the current value minus the reference value and use that number in the numerator, removing minus 1 from the result. So let's do this again. So the current delta is equal to the difference between current value minus reference value. We use the current delta in the numerator and we remove minus 1. I click enter just to make sure that the numbers don't change, so still valid. But let's continue. Now, the final step is this divide, which I store in another variable, result. So the result is the division of current delta by reference value. I can write this in a single line. I don't need to keep this in two different lines. And at the end, I return the value of result. So the reason why I use result as the name of the last variable is because I expect that the final return instruction in my measure is always return result, because I know that this is what I expect to return from the original measure. So if I click enter and I see the result, still the same. But think about what we did so far. Now, every step of the calculation has a different name in a different variable. If I want to inspect the content or the result of an intermediate step of the calculation, I can just change the name after return, and I can restore return result once I complete my test. So for example, if I write current value, I see the value of this measure that, of course, I expect to be the same number that we see for the value of the brand. Of course, the percentage is different, but if you look at the numbers and you understand that the percentage is the same value multiplied by 100, you can easily see that we're just computing the same value at this point. Now, what happens for the reference value? So if I use the reference value now, I see that the reference value is this number. And now I can already see something interesting. You see that for every brand in every year, I'm going to divide the amount of the average transaction by the number that we see here, which is always the same for every brand. Now, if you think about the original requirement, my original requirement was I want to divide the number of the average transaction by the number of the average transaction for the current brand. So this calculation should have happened brand by brand, whereas we see a different number for every brand, and we should have expected 0 in the delta average, and the number, if you remember, was different for every brand. If you look at this particular number, which is always the same displayed in every brand and in every year, we see that this is the same number we have for the grand total, which corresponds to the number of the average transaction for all the brands. So what is happening is that instead of dividing the value of the average transaction by the value of the average transaction for all the years for the current brand, we are dividing the average transaction for all the brands and all the years. So now that we understand that which part of the calculation has a problem, we can probably easily try to fix it. And we have to, of course, we have to understand that the calculation that is happening here is removing the filter from both the brand and the year. Now the year is a column of the date table, so our goal is probably to remove the filter from only the columns of the date table, keeping the filter in other columns, in this particular case for the brand. So if I try to execute the code this way, and remember, I'm still returning reference value here, you see that now what I get is different and closer to what I expect. You see that now the value returned in my measure corresponds with a different format to the value of the average transaction in the total column, and this is the same number we have for every year. So basically we are removing the filter from the year and we are returning the value of every transaction for all the years. And this is different for every brand, which is exactly what I expect. Now, if I go back to my measure and I change return to return result, what I get is 0%. What I should get is 0% for the total. But now you see that the number makes more sense because this is the number, this is the comparison between this number and this number, which is a positive number, so it's 21% more than the average of all the 2 years, the entire 2 years. And in this other case, we have a value that is below the average of the 2 years selected by 19%. So now we fixed our formula this way. And the idea is that if I start writing the code this way, with this style, splitting the calculation in smaller steps in different variables, it's relatively easy to change the last line of the measure, inspect the value in the report you are building, and then once you figure out which part of the calculation has to be fixed, try to fix it, evaluate the result, the intermediate result, restore the original calculation, and look at the result. Of course, you have to manipulate the DAX code, so it's a technique that requires you to change the code and to restore the original working code if you modify other measures that were not involved in the problem. But this is a technique that doesn't require any additional tool and can be used in any report. The second technique we use is an external tool, DAX Studio. With DAX Studio, we don't have to change the code in the model. We want to create an environment. We want to use an environment where we can make any change to the code just to inspect the result, find the problem, and then fix the code in Power BI Desktop without manipulating the defined measure, with the risk of keeping there some tests that we want to remove once we consolidate the change into a working measure. So how do we use DAX Studio? First of all, we have to capture the query that is generated to populate this matrix. We have 3 pages, demo 1, 2, 3. We have always the same report with just a copy of the different measures. You see that we have 3 different copies of data average 1, 2, 3. Initially, these are the same measure, just in 3 different versions. So for every scenario, I use a different version of the measure. Now, as I said, if I enable Performance Analyzer, I can capture the query generated to populate a visual. So if I click Refresh Visual, you see that for this matrix, we have this link, Copy Query, which copies in the clipboard the text of the DAX query that is used to populate the visual. At this point, I previously installed DAX Studio in this machine, and I open DAX Studio from Power BI Desktop. This way, DAX Studio is connected to this model, and I can paste in this area, in the editor area, the code for my query. Now, this code can be executed, and we can see the result. Now, we can ignore at the moment the additional DAX code that has been generated by Power BI Desktop. What we want to see is that in order to populate a matrix, we have 2 results, 1 and 2. The first result is the result of a query used to populate the columns of the matrix. We see the year 2018, 2019, and the grand total. The query number 2 has one row for each cell of the report. So remember, even though the shape of the report is a matrix, in terms of DAX query, we have a query that requests for each cell of the matrix, for each data point, a single row. And this single row contains all the information to identify the cell. So for example, the name of the brand and the position in the column of the matrix. So 0, 1, 2 correspond to 2018, 2019, and the total. Now that we know that, we just see the numbers that have been returned to the original matrix. We see that the number is the expected 0 we want for the data average for the grand total, but for a datum we have -7%. We have the visualization in a decimal number because in this case the auto format we have in DAX Studio is not able to recognize that this is a percentage probably, or I disable the visualization, but that's fine because I want to see the value of different numbers. How? Well, the idea is that I want to inspect the result of the calculation of the data average measure. And in order to do that, first of all, I copy in the code of the query the definition of the measure, in this case data average 2, which is the measure used for this report. Right click and define measure, we have the measure defined in the query. At this point, this is a query measure that replaces the definition of the measure we have in the model. The advantage is that I can apply any change to this code. I'm not affecting the code we have in Power BI Desktop. So I can do any test I want without worrying about breaking some existing behavior we have in the model. So what can I do? Well, I know that there is a division. I want to inspect the value of the numerator and the denominator of the division. So let's comment. Control K, I have comment here. Let's comment all the lines and uncomment just the line with the numerator, average transaction. Let's also remove the comma. What I expect is now the data average 2 column in the result will include the result of average transaction, which should be a copy of the column average transaction we have on the side. So if I go in this visualization, after I execute the code, you see that the numbers are identical. So far so good, no surprises. Now we inspect the denominator. So we comment this code and we uncomment this other line, line 9, and we run the code again. Now what we should expect is that for each brand, we would like to see the same value for every row, for every column, which correspond to for every year for the same brand. We want to see the same number that we have for the grand total. In this case, for a datum, we want to see 778.97 because this is the expectation we have in order to comply with the requirement. We want to divide the value of average transaction by the value of average transaction for all the years selected. Now, if I run the code again, we see that actually the value is not what we expect. The value is always the same for every combination of brand and year, including the total. And if we go in this case at the beginning, because the result we obtain in DAX put the grand total at the beginning instead of at the bottom of the list. But we see that this number 84109 is actually the same number we have for average transaction for all the brands and all the years. So at this point, we know that this part of the calculation is the part that is broken. We consider that, maybe that all selected is what is not doing what we expect because it is removing the filter from all the columns that have been introduced in the visual, both brand and year, whereas we want to only remove the filter for any column of the date table, the year, the month, the quarter, whatever. But we don't want to touch the selection made on products or on product brand in this case. So if I change the code this way, and I execute this code this way, let's see if now the code satisfies my expectation. And yes, we see that for the grand total, the number is always 84109, which is the value of average transaction we have in this case for the column index 2, which is the grand total, and it is the same value of average transaction for the grand total, but also for a datum, which we see in this line, the number 77897 is repeated for every year for the same brand. And if we scroll down this list, we see that for every brand we have the same behavior. The value of the column index 2, which is the grand total, is repeated here for every other column. Which means that now, if I restore the other lines, and I only modified this parameter of all selected, if I execute the code now, and I add the comma after average transaction, you see that we have the value we expect. 0 for the grand total for all the years, but the value is always 0 here, but is different for every single year for every single brand. At this point, after we validated the new version of the measure in DAX Studio, we copy this code, we go back to Power BI Desktop, we replace in the definition of delta average 2 the code we define now. So now we have this all date, we click, we confirm the measure, and we see that now we have the value 0% for the grand total and is the right number for every year in our report. So DAX Studio helped us in inspecting the DAX code, the intermediate result, but of course we had to use some understanding of how the code, the DAX code, generated the intermediate table that then is used by Power BI to populate the visual. Now, in this particular case, we had to use the query for the visual because we had to investigate on a problem using all selected. But it's worth to mention that if I just want to inspect a specific measure and I know the filters applied for that measure, if I don't have all selected involved, I could use another simpler technique in DAX Studio. For example, if I go back to DAX Studio, and let's say that I want to inspect just the value of a variable. So let's write evaluate, and then I can write a single table constructor with the name of the value of the variable. For example, data average 2. This is the simplest code you can write in DAX Studio to execute a single measure. A table that has one row, one column, and one measure reference. Now, if we know that we want to inspect what happens when we execute this measure for a particular brand and a particular year, what we can do is we say, well, I want to filter the product brand is equal to a datum, and the date, let's see if I can see the date, oops. Okay, it's not working as I expect. So the date year, I think, remember, okay, date year, you can also use this technique. Date year should be equal to, let's say 2018. Just making a sample, I think is a number. If you're not sure, you can just move the mouse over there and see the content and also see the data type, which is a number, so it should be correct. I execute this code and I see the result. Now, this is not correct. Let me think. So the product brand is a datum for 2018. Oh, yes, because in this case, we are using all selected. So let's use a measure that doesn't involve all selected. So, for example, just average transaction, because otherwise, of course, I cannot use all selected in this case. So we see that this is the value for the average transaction for this brand and this year. We can set this to 2019 and we see a different value. So imagine that you have a problem with the measure average transaction. What you can do, you can just copy and paste, search for average transaction here, move the cursor in this position and define the measure. So again, this is one technique you can use in DAX Studio to inspect a single measure for a particular combination of filters without having to capture the entire DAX query, which is still something you have to do for more complex measures, especially when all selected is involved. The third technique we analyze is the relatively new function evaluate and log we have in DAX. The function evaluate and log allow us to inspect the result of a DAX expression while we execute the code, sending the output to a specific profiler event that can be displayed with an external tool. As of today, we are going to use a specific tool that is called DAX debug output, and in the future, we hope that this feature will be also included in DAX Studio. So let's take a look at how this feature works. So we prepared another example, demo 3, with the measure delta average 3, which is the measure we're going to execute. Now, the idea is that we have this function called evaluate and log, which allow us to inspect the value of a DAX expression. In our case, we know that the division is producing a wrong result, so we want to inspect the value of the numerator and the denominator of the division. So by using evaluate and log, we can say, okay, I want to execute this code. Evaluate and log returns the same result that has been provided as the first argument. And so this presence of evaluate and log will not change the result of the report. So let's do the same also for the denominator. And if I execute the code this way, I confirm this measure, nothing changes at this point. However, what is happening is that now, during the execution of the report, the value of the result of average transaction for each cell of the report is sent to a profiler event that can be intercepted by an external tool. Because we will have many different information, the numerator, the denominator, we have additional parameters that we can use to easily identify the information that we generated. For example, we want to create a label to say this is the numerator, and with the other expression, we want to say this is the denominator. So we just write a string, numerator and denominator, because this will help us to understand what is going on. Once again, when I click enter, nothing happens. What I need to do is I have to use an external tool. This external tool today is this tool that I already prepared in this window, DAX debug output. DAX debug output can be downloaded using the link that you will find in the article. And once you open this tool is not fully integrated as an external tool in Power BI Desktop, so we have to establish a connection to the current running report. So when you click connect in the connection dialog, you select the instance of Power BI Desktop running with the file that you have. We click OK. And now, from now on, we will see the events when we refresh the report. Now, in order to refresh the report, I have to commit an action that will generate the refresh. I could, for example, change a slicer or apply some change to the measure. I just add a space this way because this forces the execution of the report again. Now, as you see, we actually have more information, because what happens is that this tool, DAX debug output, is capturing all the profiler events, but those that are interesting for us are these DAX evaluation log events. So what is happening is that for each execution in each cardinality of that measure, we have an event that displays the result for that specific cardinality. What does it mean? Let's take a look at the report. Because if we look at the report, we can better understand what we have in the list of the events. The report has a granularity for the average transaction and the delta average 3 measures, which is by year and brand. So year and brand is the grouping condition for my measure delta average 3. And in delta average 3, we have to evaluate and log. So for the cardinality year and brand, we have two events, one for the numerator, one for the denominator. If we continue to examine this report, we see that we have an area where we have a different cardinality. In this case, we are grouping data by brand, but not by year, because the number we see in delta average 3 in the last column is the value of the brand A datum for all the years. So once again, we have a different cardinality and a different set of two evaluate and log. Same happens for the total for a particular year. In this case, we're grouping by year. We're not grouping by brand. We have all the brands. And finally, we have this area, which is the grand total. Let me highlight this area. This area is the grand total. This is the no grouping at all. So let me recap. We have one area is this. One area is this. One area is this. And finally, the grand total. So we have 4 different granularities. For each granularity, we have 2 evaluate and log statements that have to be executed. Now, if we look at the numbers, at the list of the events we have in at the DAX debug output, let me see if I can find my mouse. You see that we have 1, 2, 3, 4, 5, 6, 7, 8 events, which means that for each cardinality and each evaluate and log function, we have 1 line. For example, let's start from the first one. The first one shows the label numerator. You see here, numerator. And this label numerator is showing the value of the evaluate and log for the numerator of the division for the combination of year and brand. You see that the columns we have in this area, year and brand, provides the, let's say, the cardinality, so the exact location of the result, and this is the value. So in a single evaluate and log, we have all the values that have been computed for that specific cardinality, year and brand. Next row, we have the information at the denominator. Surprising, in this case, we have a single value. We don't have a group by year and brand. And we know that the number we would have expected should have had a different value at least for each brand, because the denominator should have removed the filter for the year, not for the brand. We know that we have seen that we have a bug, but the idea is that the information provided here does not provide actually the expectation we have. I have to say that we have to infer this behavior because we don't have the information about the filter context where originally this evaluate and log has been executed. We only see the result of the execution. We don't know in which of these of those 4 areas this event has been triggered. So if we continue, we see that now we have again the numerator, this time for just year. We have a value for each year. So this is the area that computes the value by year. It was the bottom one. Then we have the denominator, which once again is only 1 value. And if we continue, we have the numerator this time by brand. This is the total for all the years by brand. And once again, the denominator is always the same value. And then we have the value for the numerator. This is the grand total, numerator in the grand total, and denominator for the grand total. This is the only case where the number is correct, because it's the case where we didn't have any filter, any initial filter. So I would say that this is an interesting information because it provides me an insight about how the engine is computing is preparing the data for all the sets of my report, how many internal calculations have been performed. It could be not intuitive to understand what is going on, especially when you have many calculations involved. Now, by going by exclusion, because we see that all the event denominator do not provide a group by brand, this is an information we could use to understand that probably that part of the calculation is not working well. So at this point, we go back to our Power BI desktop definition and we fix all selected so that all selected removes the filter only from the columns of the date table. So let me write this in a better formatted way. And if I click enter now, of course, this fixes the problem. And if we go back to the DAX debug output tool, we can see that now DAX evaluation and log first event for the numerator, same as before, we have year and brand. But then the second event has now the value grouped by brand. We removed, we all selected the filter from the year column in the date table, but we kept the filter for the brand. And this, of course, continue for all the other calculations. In this case, we have only the group by year and the total, of course, removes the year. In this case, we have the group by brand, so the value is the same in this case because we don't have the year to remove, and the grand total, no differences. So evaluate and log is very useful, but it needs an external tool to analyze the result of this execution. It provides a deeper insight about the calculation engine. It could be not the more intuitive way to understand the impact of the calculation when you want to analyze the code step by step. We are not able to analyze the behavior of a single cell. We always see the result of the measure computed for the entire visual where you apply the measure that uses evaluate and log. The last technique we analyze is how to understand where an issue is in a calculation by using the DAX debugger feature included in Tabular Editor 3. This is a commercial product that is not available for free, but I want to show this tool because it's very important. It's the only DAX debugger available in the market today, and it provides me the experience of analyzing the calculation step by step, something that I wasn't able to do, for example, by using evaluate and log. So we have Tabular Editor installed on this machine. We have the fourth example, demo 4, which is always the same measure, the initial measure we had with a bug we have seen before. By clicking this button, Tabular Editor 3, we open an instance of Tabular Editor 3 connected to our model. So in order to understand what is going on, once again, we start from the query that we can capture by using the performance analyzer. Why this? Because we know, in this case, that we want to investigate on an issue that is happening in a particular cell of this report. So we want to be sure that we investigate that particular cell. And the cell we want to investigate, for example, is this A datum data average 4 measure for the total of all the 2 years selected. So step number 1, we go to performance analyzer, we start recording, refresh visual, go in matrix and copy the query. Now we have the query in the clipboard, and similar to what we did in DAX Studio, we paste this code in a specific feature we have in Tabular Editor 3, which is a query window. We can open a new DAX query window and we can paste the code we have in the clipboard. At this point, we can execute the code. Query execute. So far, we use the feature that is very similar to what we have in DAX Studio. The difference is that at this point, once we inspect the result number 2 of the query, so the result is the same we have seen in DAX Studio, but the difference is that I can right-click the data average measure for A datum column 2, which correspond to the total, right-click and use this feature, debug cell. Debug cell will open the experience of the DAX debugger. The DAX debugger automatically included the definition of the measures involved. We have not just data average 4, but also average transaction, because we could step into the execution this way. And we have these buttons here, step over or step into, which allow us to execute the code step by step. Now, let me enlarge this area so we can see better. We need more space to display the information. We can also reduce the messages and have more space for these 2 windows, which are locals and evaluation context. So we have very useful information at this point. Let's see if I can enlarge this a little bit. I have this symbol is okay. We can continue this way. I don't like the way the symbol is overriding part of the name, but I think we can live with it and we can move forward. So you see that we are investigating the evaluation of a cell that is computing this measure. The entire measure highlighted is displayed in current expression in the locals. So locals shows the value returned by the entire measure and the result of the division. However, the debugger understands that the expression contains other expressions, other sub-expressions, and already shows the result of intermediate step of the calculation. We can see the result of the division. Remember, the total of data average 4 is the number of the division minus 1, which means that this is the value before the subtraction. And average transaction is the result of the measure average transaction we used in the numerator. This is a local, so it already shows me something that happened inside. And in this other window, evaluation context, we see the state of the evaluation context. The evaluation context is the set of filter context and row context. At this stage, we don't have any row context, we just have a filter context. But we see how this filter context has been built, looking at the stack of the filter that have been applied to the filter context. What we see now is that starting from an empty filter context, we applied a filter through summarized columns. What is happening is that the query, the DAX query, is executing a function called summarized columns that inject two filters in the filter context. One is over product brand, and one is over this, it comes from this DS0 filter table, which, if we go back to DAX query, corresponds to, let's see if I can enlarge a little bit the font, correspond to these three tags. These three tags is basically the DAX translation of the filter, the filter over the date year I had in the filter pane of my report. So this means that the evaluation of the measure of the expression that we have in the filter currently highlighted in the DAX debugger is evaluating a filter content that has 2 years, 2018, 2019, and one brand, a datum. So we are inspecting a single cell in the execution of the calculation. At this point, though, we still don't see the problem. If you remember, we had to see that the result of calculate was an issue. But what we can do, we can use step in to go inside the execution. So step in, now enter the execution. At this stage, it didn't change much. We're just executing the same content of the expression we have in the measure. So we do a step in again. And now you see that only the divide is considered. You see that because we are considering only the divide, at this point we have two measures that are displayed in locals. Two expressions that are displayed in local. One is the average transaction, which is the numerator, and the other is the calculate average transaction all selected, that is our denominator. So by looking at this code, we can see that already the value of the denominator is already visible here. Of course, in this case, we only see the value of a single cell, so we don't immediately perceive that this number is the same for all the brands and all the years, and probably is something that does not correspond to our expectation. So in this particular case, the previous techniques may have been better to immediately understand that the number was corresponding to the grand total. But what we can do here is continue to go step by step to understand what is happening also at the filter context level. So if I go and I click step into again, now I'm gonna execute average transaction. And I could enter into average transaction. If I go to step into, you see that now we enter into the definition of average transaction, and we can see, once again, current expression, filter content, what is going on. Now, because I'm not interested in iterating thousands of rows in the sales table, I can just step out. So I go back, it's like step back and go back to average transaction. And in this case, I don't want to go into average transaction. I want to just step over. So I want to skip this evaluation, go to the next argument of divide. Now this argument is calculate. How calculate is executed? Calculate gets the current filter context, applies different filter, performs a context transition if there is a row context, and then evaluate the first argument. Indeed, if I go into this evaluation, the first argument executed is all selected. And all selected will apply changes to what? To the filter context. Look at the evaluation context, that is our current filter context. If I go and I step in, because there is nothing inside all selected we can analyze, we see that the result now is the evaluation of the first argument average transaction. But look at what is happening. This average transaction is evaluated in a filter context that has, let me highlight this. To this filter that was applied by summarize columns, this other filter all selected has been applied. Actually, this all selected is applying a removal of this filter and this filter. And because of a bug of this version of Tabular Editor 3 I'm using now, you don't see that these two filters have been removed. We will see that this is working with another example I will show you later, and this fix is expected to be fixed. This bug is expected to be fixed soon, so maybe, I don't know if by the time you will see the video, but maybe in a future release of Tabular Editor, this bug should be fixed. And we should see the final result of the filter context in this visualization. So let's go back at this point. And of course, if I evaluate, and I can use the step over in this case, I can evaluate this and I can obtain the number we have seen before. If I roll back, if I step back to average transaction, you can see that the result of average transaction is this number, which is computed in this evaluation context. Now, let's say that by doing this evaluation step by step, that is much more useful and helpful when we have a calculation that doesn't depend on all selected, because in this case, all selected is a complex example to show, but I wanted to show something that is not trivial, to show all the possible features of the different techniques and tools. What we can do at this point, we can fix the code into the model. So we go back to our model, we fix the code. We can remove this one. We can fix the code because we know that we have to fix this in all date, because I want to show you what happens when the code is fixed. Of course, now we fix the number, but once again, my goal is to show what happens when we have this debugger. So let's go back to, so let's execute this code again. Query execute. Let's move this down. And at this point, I should see that the number is 0, 0. So now we fix the problem. This is the same experience we could have used in DAX Studio by comparing the numbers in different brands and years. But once again, if I debug the cell now and I go in the debugger, you see that now the measure has been fixed. We see the different calculation. If I repeat the process of step into, when I approach, oh, sorry, I don't want to do this. Step back. Oh, step out. Step out. Okay, I want to step over. Still have to make practice and remember all the shortcuts, but I wanted to use the buttons because if I use the function button, it is not clear what I'm doing. So now I step into again, and you see that at this stage we are going to execute all selected, and we don't see anything in the filter context. But as soon as I step into the first into the next argument, average transaction, now you can see that, let's open this, you can see that because we have all selected, this filter has been removed. And as I said, all selected without any argument should have produced the removal of this filter, which is the current bug we have in this version of Tabular Editor. Hopefully this will be fixed soon. So this is what we can do by using the debugger in Tabular Editor 3. And I think it's a very, very powerful tool to actually see what happens step by step, not only for the single expression, but also to the filter context and the evaluation context in general, which is an information that we weren't able to get with all the other three techniques that we have seen so far. So we have seen 4 different techniques to debug DAX measures. The first one is just using the measure definition using variables to split the execution of the code in smaller steps. This makes it easier not only to read the code, but also to inspect the code later, because you can just change the final return statement of the measure, displaying the intermediate step of the calculation in an easy way in the same report where you are, and then you restore the original execution by using the last variable, which is usually result. Of course, this technique does not help you too much when you have a very complex report and you have to inspect complex interactions, so you have a very nested set of measures. You want to investigate what happens at a particular point, and at this point we use external tools to help us doing the job. The first one is DAX Studio, where we can just copy the query executed by Power BI to populate a visual. We can add local versions of the measures. We call these query measures. We can manipulate these measures to inspect what happens without touching and without the risk of damaging the original model. It is an effective technique, but of course, it doesn't provide me an additional help in understanding what is the internal execution or the internal evaluation context executed at a certain point. Then we have seen DAX debug output, which is a tool that displays the result produced by evaluate and log. By using evaluate and log, we can intercept a particular expression during the execution of a measure, and we can show the content of this expression in a profiler event that can be captured by DAX debug output tool, or in the future, hopefully also by DAX Studio in a specific window. However, we have seen that while the information provided by evaluate and log and DAX debug output is very helpful to understand how the engine works internally, sometimes it could be not immediately understandable to get an idea about where a calculation issue is. So the other and the final tool we have seen is a real debugger. DAX Debugger is a feature in Tabular Editor 3, which actually can get the existing code without touching anything. We can execute the code step by step and see what happens without having to rewrite the code. DAX Debugger also provides useful information about the evaluation context, something that is hard to obtain in the other techniques we have seen. So probably we need to know all of them. I think that the feature in DAX Debugger in Tabular Editor helps your productivity, but of course we could obtain the same information by writing more code in DAX Studio or in the measure using evaluate and log, getting the value from the filter context using filters, using values, and other DAX functions to inspect the evaluation context. Of course, it takes more time and is not as fast as DAX Debugger. But remember, even just organizing the code, splitting the code in smaller steps in variable is always effective, it has no cost, and it helps you writing better code that is easier to investigate. As usual, enjoy DAX!